Well, hello there everyone, and guess what I am here to talk about today? Physics. Don't worry, we're not talking about math today. I'm just going to teach you the concepts. I figured while I'm on my physicist journey, why not share each semester what I've learned so that way you guys can understand the world around you, because after all, physics teaches us to see the unseen world. One second. I should have took that out. Alright, so let's get started with the presentation. So you may ask, what do you learn in your first year of physics? Well, currently I just finished my first semester, and that was about kinematics, which means motion. So we studied how motion works and how to measure motion in the unseen world. So next semester, when I go to spring semester, we're going to be learning about electromagnetism, which basically means we learn how electricity generates a magnetic field and how we can manipulate the magnetic field to manipulate the unseen world. So you guys will see me in another 3 months to talk about more physics to explain that part. So what is the most important concept that I learned in physics this semester? Well, Newton's laws of motion. You guys remember Newton, the guy that sat underneath the tree and had an apple fall on his head and he understood gravity? Well, Newton has 3 laws of motion. 1, if an object is in motion, it stays in motion, and if it's at rest, it stays at rest. Don't worry, I'm going to break these concepts down further. The second law of force can be calculated by taking the mass and how fast it's going and doing math with it. Don't worry, I'm not going to explain it too farther than that. And then the third law means everything has an equal and opposite reaction, which is also important to understand why things stay still versus moving. So in the first law, as you see in this picture right here, believe it or not, everything in the universe is moving. We are not stationary. I was very shocked to learn this semester. And this is how actually the solar system is spinning throughout the universe as we speak right now. So that explains the first law. If everything in space is moving, then they're staying moving unless something hits them to stop them from moving. So if you think about it that way, everything is fixated in the world unless something knocks it out of its course. But how often is that going to happen? Because everything is fixed. Because if you're in motion, you're stuck in motion. And if you're not in motion, then you're not in motion. So this means that you have to have something to interact with you to push you off course, basically. So how do we describe motion? There are 3 ways to describe motion. We have speed, which just basically means how fast you're going. We have velocity, which means how fast you're going, but how far are you moving from where you originally started traveling. And then acceleration, which is how fast you're moving, but how fast you're moving, and it takes you how much time to travel from where you started. It takes a while to learn the difference between the 3. However, we're going to be focusing on acceleration the most because, for example, if you were at a constant speed, then you're not accelerating, and therefore you do not have a force acting on you. Which moves on to the second law, which means a force can be measured through 2 things. A mass, which is completely different from weight. Weight is actually a force that you feel based off of the gravity that you're on. So, for example, if you're 110 pounds, that's the force of gravity you're feeling on Earth. So if you were on a different planet, you may weigh less or you may weigh more depending on the gravity. And another thing, mass just basically means anything that takes up space. So that's how you describe mass. And that's how you describe something in the unseen world. If it can take up an area or region of space that we can't see, then it has mass because you can tangibly measure it. And if it has mass, then it can accelerate and move because it can interact with the field around it. So, moving on to the third law, everything has an equal and opposite reaction. Well, if that's the case, then how does anything move? Because if I push you, then you push me back, and therefore none of us is moving. Well, actually, one of us has to move if we weigh differently. Think about this. A 100-pound person versus a 200-pound person are pushing each other. The 100-pound person is going to look like they're moving. However, they're both pushing each other with the same force. It's just the smaller person, in order to push back, has to move in order to equal the force that they're pushing onto the 200-pound person. So basically, they have to apply a force twice as much to match the 200-pound person. And this is what we mean by everything has an equal and opposite reaction and how we're able to measure forces. So to quickly break down how forces are measured, you can measure them through a graph, and you have arrows pointing in a direction. This is how we can measure in any direction. Up, down, left, right, anywhere you point, it's a direction, and we can measure it in physics. And through this is how we're able to tell how far something is moving, how fast it's moving, and how much it weighs. So, as I said, there are 3 types of motion. We have linear motion, which means one-dimensional, circular motion, which means in a circle, and then rotational means you're doing a circle but you're rotating while a circle, which I'll show because that's in 3 dimensions. So first we have the 0 dimension, which is literally just a dot, and there's no motion because you're just a dot. Then we have 1 dimension where you're a line, and you can only go in one direction depending on which way the line is pointing. And then you have 2 dimensions, which means you can either go left or right, or like up and down like this. And then we have 3 dimensions, which is the reality we live in. And 3 dimensions means you're able to move in 3 directions in space. And then there's multiple dimensions, really. There's 10 dimensions described in physics. However, we are unable to comprehend any dimension above the 3rd dimension because it is hard for us to comprehend a fourth direction outside of what we can comprehend. So to quickly break down what straight motion is, I'm going to be giving you guys now examples of each of these types of motion so you can clearly understand how the world around us works. So straight linear motion, imagine you're driving on a car on a highway. You're just driving straight. That's straight motion. Another type of straight motion, you're on an elevator going up and down. Those are 2 ways we can describe motion. And as this picture has a straight motion, if you throw a bowling ball, it's having rotational motion while moving straight, which is what you'll see later on in the video.
Okay, so here's how we're gonna do this. So I have my trailer here with some wheels connected to the back of the trailer here, so that when I open it, these are gonna drag on the ground. Then I'll get in the trailer and I'm gonna try to match the exact same speed as the car when I'm running, so that when I run and jump off it, I'm gonna exactly equal the speed of the ground and I shouldn't be moving whatsoever. Okay, you can start. Let's go for it. Okay, stay constant. Holy cow, this is fast. Oh man, that is so cool.
Next, we're going to move on to projectile motion, which is a motion in 2 directions. Which means, for example, if you're thinking about a cannonball being shot out of a cannon, that's a projectile because it makes a curved path. Also, if you think about in this picture right here, somebody shooting a basketball, the basketball has a curved trajectory. And this is actually how they get satellites up into space to orbit Earth. They angle it in a specific way that the satellite is, as they call it, constantly falling towards Earth, but because it's at a fast speed past its escape velocity, which means it's faster than the Earth, so therefore it's not falling into Earth exactly, it's just always slightly missing it, which is why it's constantly rotating in a circular motion around the Earth. So this is how physicists use basically physics to describe astronomy and the solar system and how the universe works. Because that's another unseen universe, because it's literally so far away and bigger than us that it's really hard and almost intangible to try to understand it without complex math and physics.
Why do projectiles do what they do? Let's learn physics. We'll start with a couple guessemonstrations. Here's a cart, launches a ball vertically upward. It's spring-loaded, has a pin underneath that's attached to a string. Pull on the string to release the ball. So what's going to happen? Where's the ball going to land? Did you predict that? Listen to the slow-mo. Interesting. Horizontal.
So moving on to circular motion, which is, if you're probably wondering, if we were talking about projectile and we had a curved path, a circular motion is that curved path is now fully continuing its path, as I was just talking about with the Earth. So this, another example to try to figure out how this works in astronomy sense. Planets orbit the sun, so therefore that's circular motion, because the planets are always going around the sun, and it's the force of the sun's gravity that constantly drags the planets to them to make them free fall or constantly fall towards the sun. But because they're going so fast, they are just always slightly missing the sun, just like the satellite does around the Earth. And I have this video right here to show you guys of a professor that explains this exact motion. Okay.
A satellite is released from a rocket at a specific distance from Earth. There, it keeps going around Earth in a circular path, an orbit. This happens because there is a balance between the energy the satellite picked up from the rocket, called momentum, and the pull of Earth's gravity. The balance of these two forces can keep a satellite in orbit for many years. But
we're going to move next onto rotational motion, which, to understand rotational motion, to keep on the theme of the planets, remember how I said the satellites orbiting the Earth was circular motion, while the Earth rotates on its axis. That's why we have a 24-hour day cycle, because that's the Earth turning around on itself as it orbits around the sun. So therefore the rotational motion as a third axis, because the rotation is through the center of the Earth or whatever object is spinning. And an example to understand that more on a physical level is a merry-go-round. All the horses or whatever's on, I know these are weird examples that they actually use to teach us in physics, but it's something everybody has seen before, so it makes it easier to understand. Everything on the merry-go-round is rotating around the center, and that's why you're having this rotational motion. But on top of that, the merry-go-round itself is actually spinning while you're spinning on top of that, so it's a double rotation. And here's a video to explain that, and they call this concept angular momentum, which basically means, depending on how much mass you have, you will spin faster or slower depending on the force that was put onto you, and you have to keep that motion. So imagine if you lost weight while spinning through space. Well, if you were much bigger, you were rotating slow, so now you're going to rotate even faster because you weigh less, and to keep that speed, to keep that force constant, you're going to have to grow your speed. So here's an example of the video to explain this.
The axis, I'm going to rotate it about this vertical axis, and that axis is also denoted by the string that passes vertically through the sphere. We will, if we give it some angular momentum in the expanded high moment of inertia configuration, and then we contract it, its angular speed should increase.
much. This is what I have learned throughout the semester of, well, this is what I've learned for the last 3 months in college about physics. And hopefully I was able to show you guys a bit better about how to understand the world around you. And when a pencil, for example, falls on the floor, you can maybe start thinking about what are the tangible reasons for why a pencil fell on the floor. But also a great thing I love about physics, because this is an esoteric station after all, physics can help you to see the unseen world. Therefore you can explain weird phenomena that they might consider paranormal. However, it's just higher dimensional beings interacting with us in ways we can't comprehend because they're above us. But we have ways to interact with them and measure what they're trying to say to us or communicate with us through these different types of energies. And this is what physics is really about, and this is what, as I talked about early in this channel, what CERN is about over there in the European Council of Nuclear Research, how they're making black holes, trying to understand what makes the universe work. These are things that physicists do because they study the unseen world and how we materialized from particles that we cannot see from. So with that, I hope you guys enjoyed this video, and I will see you guys next year. And with that being said, like, comment, subscribe. We are almost at 500. I know tomorrow is a new year, but let's try to get those numbers up, guys, because we have almost been on YouTube for a year. It will be a year in February, and it has been a great journey with you guys, and we hope to continue to grow this station. So with that being said, enjoy your New Year's, and I hope you walked away just a tad bit smarter. All right, bye.